Okay, so in this chapter, we've been talking about linear inequalities. But notice they've always had only one variable. So in this last section of this chapter, we're going to talk about, well, what about linear inequalities with two variables? Remember, when you have two variables, we can't solve it. Right? Not if we have one equation. We can't solve an inequality or an equation with two variables. So we said, oh, well, we draw a picture of what the solution looks like. So we're graphing when we introduce two variables. Okay, so if we're graphing linear inequalities, we're going to imagine that the less than or greater than, whatever it is, let's just imagine it's an equal sign and find out where the line is. Think about what happens. Let's think about one number line. If I said x equals 3, then the only thing that can happen is on one side of 3, everything's bigger. On the other side, everything's littler than 3. And then at 3 is where it's equal. So if I can find the line where x plus 5 equals 5, hey, on one side of that line, everything has to be bigger than 5, and on the other side, less than 5. So that's going to be our method. I'm going to first imagine that it's an equal and find 2 points so I can graph the line. Now, sometimes we're going to have a less than, sometimes we're going to have a less than or equals. So if we have the equal part, we're going to draw a solid line. If it's less than, I'm still going to have the same line, but I'm going to make it dotted. That's going to tell me, hey, that line isn't part of my answer. It's like putting a parenthesis. That number is not part of my answer, but I'm going to go all the way up to that line. Okay? And then I'm going to shade the side that's bigger or less than. And as we do it, we'll explain how we know that. Okay, so again, there's some steps if you want to pause it and read over that. I'm just going to jump right in. All right. So, obviously it says graph, and there's a little grid there, so I know I'm graphing. But if it just said solve x plus y less than or equal to 4, my first thought is, oh, there's an x and a y. The only way I can solve that is draw a graph. Okay? All right. Now remember, I'm going to just imagine, to start with, that I need to find the line where x plus y equals 4. Use whatever method you prefer from before, but this one's set up perfectly for substitution. Okay, if x is 0, in other words, if that's gone, then y is 4. If y is 0, so that's gone, x is 4. That's your 2 points. So by whatever method you want, get your 2 points. Now, because this one actually has the equal part, I want to draw a solid line, just like if I was just doing the x plus y equals 4. Okay, but now I also have to account for the less than 4 part. So the way I'm going to do that is I'm going to choose a test point. If my line doesn't go through the origin, I'm always going to choose this test point as 0, 0, because remember how easy it is to plug 0 into things? So if this is the point 0, 0, x is 0 and y is 0, let's plug it in up here, 0 less than 4, and ask myself this equation. Is it true or not? Is 0 less than 4? If that's true, this is the side that my answer is on, and I'm going to shade this side. If that's not true, then this would be the side that's greater, and I'd shade the other side. That's all there is to graphing these inequalities. Okay, they didn't give me a graph. Oh no. See if I can kind of draw one right quick. Okay. So I'm just going to imagine that it's an equal. X and Y is on the same side. I'm going to use the intercept method. If X is 0, Y is 0. Uh-oh. I only get 1 point. So I have to find another point. Any point. It doesn't matter, right? So let's just let X be 2. Okay, so if X is 2, Y is negative 2. Okay, so I get another point. X is 2, Y is negative 2. Okay, now I have to decide, do I draw a solid or a dotted line? And because it does not have the equal part, I draw a dotted line through those 2 points. Because this equation goes through the origin, I cannot pick that point. So I could pick this point if you want to pick 1, 0 or 0, 1, but I like to, if possible, I like to pick points where my X and Y are the same. That way I don't have to worry about getting them mixed up. So this is the point 1, 1. So I'm going to plug it in up here and ask myself, is 1 plus 1 greater than 0? Is 2 greater than 0? Yeah, 2 is greater than 0, so that point's on my answer side. So that's the side I shade. It's as simple as that. Let's try it again. What's up with them not giving me graphs? Okay, whoops. Now on this one, notice, luckily, hopefully, it says graph. Because I wouldn't know that if it didn't tell me graph, because this one's special. It only has 1 letter, right? 1 letter. I gotta know if I'm graphing and I have 1 variable, it's one of those special situations. Okay, so it's either a horizontal or a vertical line. That's what I know by it being special, right? So Y is less than or equal to negative 4. Here's where Y is negative 4. All right, so it's a horizontal line. It's going to be a solid line because it has the equal. Okay, now I could also pick this point 0, 0 and plug in the 1. Plug in the 0 and ask myself, is 0 less than negative 4? No, it's not. So I don't shade this side, shade the other. But also when I get those special situations, I can also just think about, well, what's less than negative? Less than is on this side. Right. When I have a slanted line, I can't tell those combinations, what makes it positive or negative. But hey, if it's just the Y, down here is less than negative 4 and up there is greater. Or you could plug in. It told us the same thing. Okay, they gave us a grid this time. Okay, so I'm trying to blame them. I know that's my fault, guys, because I went in and adjusted all these. to say what we needed to say. All right, so this one's set up perfectly to do the slope-intercept. Okay, and again, I'm just going to imagine it's an equation. I know that my y-intercept is 3, and a slope is -1/2. So -1/2. Or I could do +1 backwards 2, either way. Either way. Get me a couple of easy points. Line will be dotted. Line will be dotted. And which side do I shade? Let's pick the point 0, 0. So that means this is 0. This would be 0. Is 0 less than 3? Yes, it is. Shade that side then. All right, one more. Okay. This one is set up perfectly for the intercept method. So first, I just imagine it's an equation so I can find that boundary line. Okay, if x is 0, this is gone, y is 4. If y is 0, this is gone, x is 5. Okay, the line will be dotted because it's strictly greater than. So I'm going to draw a dotted line through here. And then decide which side to shade. Let's pick 0, 0. 4 times 0, that would be 0. 5 times 0 is 0. 0 plus 0. So here's my question. That's why 0 is the great point to pick. Is 0 bigger than 20? No. Do not shade that side then. Shade the other side. Okay. And that wraps up chapter 8. We're getting close. Let me know if you have any questions.